Group theory. Group theory. What is group theory? It's an algebra, actually. The group theory was initially invented by the French mathematics genius Galois. He was very young. He was teaching in school the music, and he loves math so much that turned the music class into a math class. But he died very young, before 30, I think. He was genius. He made his group theories and published it, but over 50 years nobody's looked it up, and later they found it. What is group theory? Group theory is a foundation of algebra. Algebra, everybody learned from elementary school to middle schools, and we are without much mathematics structures, just number to additions and multiplication and stuff. Group theory completely make it mathematics. It's abstract level mathematics and define everything clearly. Okay, so math start with definition. What is a group? Group, there are several conditions. A set means a group of something has an operation that is closed. Closed means after operation. If operation is addition, A plus B produce C, the element within the same group. That means it's closed. Okay. If some operation like a square root, this -1 square root, jump out of the real numbers, become imaginary number, that's not closed. Okay. The addition operation is closed. Okay. The set has identity element, means A plus 0 is A. Identity element is you operate, you get the same result. Okay. And the set has inverse element. Inverse element is negative number. A plus negative A is 0. Okay, inverse element is if you operate it, then you get 0. The identity element, that's inverse element. And also the operation is associative. Associative is A plus B plus C is same as A plus B plus C. Okay, and number 5 is optional. Okay, allow the commutative rule. A plus B equals B plus A. And if you have a condition 5 is called commutative group. Without it, it's just a group. So what's so big deal about the group? Integer satisfy everything, right? Okay, so integer plus operation define the group. This is a very good example. Okay, the elementary school student knows this without mathematical definition, but it's much more abstract concept. For example, you have something like this 1 2 3 4 and define it as this way. You rotate 1 like a Rubik cube. Rotate 1 is plus 1, rotate 2 is plus 2. You define this operation plus 3, and this way it's -1 and -2 and -3, and this set is a group. And we can define plus means plus 1 and plus 3 means rotate once and 3 times and come back to 0. Okay, so this itself you can construct mathematics, algebra. Okay, so potentially by defining properly, you can probably solve the Rubik cube using algebra. Okay, that's the power of abstract math. Use the math abstract concept to solve the problem, and that's what you can do with this group. Now it's upgrade the group to the ring. What is ring? group has the additional operation. Okay, it must be group first. Okay, and that is closed. Additional operations, something like a multiply, A times B, is closed. The generate C, which is in the same set. Okay, so that is closed. Additional operation has identity element. What is identity element? You operate, you get the same result. A times 1 is A. And the additional operation has the inverse element. A times A over A equals 1. Inverse element is reciprocal number. Okay, and rational number is guaranteed to have a reciprocal number for any number in the rational number. Okay, so operation can be associated rule. A times B times C is A times B times C. Okay, this already satisfied in the rational number. When the operation allow commutative rule, A times B equal B times A, called commutative ring. Okay, so this is option, just like a group. Now, the ring, the good example is, again, elementary school student knows this. Rational number. Rational number is commutative ring. Okay, the integer is commutative group. Rational number is commutative ring. And for example, we can add another operation for the example we generated, the spinning the box. 1 means it doesn't do anything. Plus 1 means you swap diagonally this way. And plus 2, you swap this way. And plus 3 means you swap both. Okay, if you define that kind of operation, then we can have a ring. So this cubes, we can have a ring, and we can have more operation if it's 3D Rubik cube. Okay, we can define more operation, this way or this way or this way, right? So after you define that using algebra, we can make a theorem and solve the Rubik cube. Okay, that's a challenge, but this is a math tool to do that. How you want to solve the Rubik cube mathematically, this is the way to do it. Now, group theory is actually much more abstract than algebra, general algebra. Algebra's good example is integer and the rational number. Those are the group and the ring. And so using the group theories, there are a lot of characteristics we can extract about integer and rational number. For example, the polynomial function, the characteristic of polynomial function can be extracted using group theory. And that's what it is. Like solving Rubik cube or some of state diagram we call is used for logical design in computer, hardware and software, and sometimes we can use group theory as a mathematical tool to solve some of the problem. Okay, so there are so many contributions in finding the characteristic of polynomial equation, and that's the pure mathematics. And using group theory, we finally understand what the integer is and what the rational number is. This is just an example of sum of group and ring. Okay, so that's all about the group theory. I hope you enjoy listening this, and please check other videos. Thank you.